Welcome back, everyone. Today we are going to talk a little bit about sockets. So a socket is a IP connection, usually. So you connect to a server somewhere on the internet or in the local network, and you send data. In our case, we're going to do a TCP connection on port 80. And 80 is the HTTP protocol, which is used for clear text communication on the web. So we're going to connect to a web server. It'll be something like this. And we're going to send an HTTP head command, which basically checks the headers of the web server. Okay, this was a bad example. I can't access this from inside the network. Let's do Google. And we'll send the head command. And this is what we get back. So usually when you send a HTTP request, you get the headers and then you get the data. But if you use the head command instead of the usual get command, you just get the headers. So it's a good way to test out if it works. And in this example, we're not going to use any DNS. So we're not going to resolve this domain address to an IP address. We are just going to supply the program with a hard-coded IP address. And we can find that IP address by doing the host command or the nslookup command, or even just ping it. And then we'll see the IP address here, and here, and here. And we're not going to use IP version 6, we're going to use IP version 4. Okay, so let's create a file. I'll code it in VI today, and we will call it sockets.c. As usual, we begin with a header and the header files. I will only include the standard IO for now. We're going to need quite a lot of includes to do this, but I will do it in the way that I begin with this one, try to compile my code, check the errors, and see if there's anything I need to add. And for some of the functions I'm going to use, I'm going to check the man pages as well. Okay, so let's do a definition constant with the IP address. And we'll use, okay, I'll just issue the command from VI like this. Let's try it again. Host and www.google.sc. Like this. So if you don't know this, you can type in the colon and an exclamation point, and then you can run any Linux command and it will show the output on the bottom of the screen. Quite nifty in cases like this. And we'll do a constant for the port as well, 80. Like this. And we will do it easy for us by putting everything inside of the main function. Okay, so what do we need in order to do this? we begin with a socket return value. So this is like a file descriptor for the socket, and it's an int. We will also need a structural type called sock address in sock. This is where we put our IP address and so forth. So let's begin by initializing the socket. So we make a call for socket, and we tell it that it should be an internet connection and a stream that is used for TCP connections. And then I believe the last argument is just a 0, if I remember correctly. Let's see if we get it right. We can take this at the same time. Okay, so domain type protocol. And these are the domain AF internet, IPv4 internet protocols. Okay, so that's right. And then we have the type, sock stream, provide sequenced, reliable two-way connection-based byte stream. So that's a TCP connection. And then, what was the last one? Protocol. Let's see what it says. Protocol. Here we are. The protocol specifies a particular protocol to be used with certain. Normally only a single protocol exists to support a particular socket type within a given product family, in which case protocol can be specified as 0. Yes, I remember correctly. Haven't done this for a couple of years, but I still got it. Alright, so I forgot to check the return value. We want to maintain good error handling. Okay, so where do we have it? Return value. On success, a file descriptor. On error, -1. So if s is less than 0, we will print out, socket error, and returns -1. -1 is a standard error code for Linux programs. Basically, it means every error. Okay, so now we have a socket initialized. Now we need to fill our sock address in structure. So we're gonna do the sock address, syn address, source address. This is the IP address of the target. And we need to call the inet address function and provide our IP address. So basically this function takes the IP address from this format and makes a big number out of it. And while we're at it, let's check if we need any includes for this one. We'll just grab those. And I forgot to do the same with the socket function. We probably take a bit too many includes when we do this way, but that's okay. Okay, socket we did twice, types age in, okay, this looks right, and 1, 2, 3, 4, 5, 6, 7, 7x, 7x, 7x. And we don't need this ugly comment over here. Okay, so now we have the destination address. We also need to put in the port. I think it's like this. And the port does also need to be formatted. I believe it changes it from big endian to low endian or something like this. It's the age ton s function. We'll just put it in our constant port over there and see if we need any includes for this one. Only one. Let's see what it does. Age ton s. The age ton s function converts the unsigned short integer host short from host byte order to network byte order. So basically that's probably if the number is like this in hex, we just change it around like this. Probably it won't do much because the port is so low, but it might. Okay, I think there is one more option we need to do. We have the IP, we have the port. I think we need to put in the SYN family as well, if I remember correctly. Do we need to put in the other one as well? Man3, no, man2 sockets, domain type protocol. We can do like this. When you're not sure of the format of a particular structure type, you could just take this one and then you grep for it with the -r, and then you search in the user include directory. We will probably get quite many, but let's see. No, nothing. Sock address in. Grep -r sock. What's his name? Sock address in. And this time we search this directory. What if we just grep for sock address? Never mind. Let's just see if it works without any additional things. The next step is to connect to the host, and then we will use the connect system call. So we do connect, and then we do we will put our sock here, but we need to typecast it to a sock address. And then we'll put the address of that. And we need the size of that structure. And there's one more argument as well. Yeah, we need to connect it to our socket. This is the right one, I think. Like this. And let's check the return value. And the header files. We do have both of these anyway. So first we have the socket file descriptor, then we have the socket address, and then we have this length. So we did it right. What about the return values then? 0 is returned if it works. Okay. So if this is not equal to 0, then we will do a printf, and this time connect error, and we'll close the socket and return -1. And we'll put some temporary stuff here and see how it looks this far. So if we just run this code, sockets.c, okay, unknown type, sock address in. So where is that structure? It shouldn't be sock dash address in. It should be like this. So that's why we didn't find anything when we search for it. So let's do this search again then. Grep r socket address in. Here we go. Okay. So where is the actual struct? Isn't this perhaps resolve.h? We'll search for that. No, it's just a part of this. Struct socket is in, and its address. No, that's not right. Let's keep on looking. Okay, so we probably had it right from the beginning, but I thought it was a type-def structure. We need to actually specify this struct. Okay, now we're a little bit closer. What does it say? Sock address is undeclared. Okay, that's probably because of that dash again. Like this. No, it's still like that. Perhaps we don't need to typecast it. Let's see what happens if we don't. Yeah, there it is again. So instead of sock address, we'll just do sock address in, like this. And once again I forget the struct. Okay, it says an incomplete pointer set. Let's check the connect manual again. Const struct sock address. So it should be a struct sock address. We tried all possible combinations but that, I think. Okay, so struct sock address and sock, compile. Okay, now we only have one left, and that's close. Where might close be? UniSTD, okay. And voila, it compiled. Okay, let's see if it runs without crashing or giving us errors. No errors. That's great. Okay, so one can assume that we managed to connect to that server. So now we just want to write something and read some bytes from it. So I will just do this. We need a buffer in order to read, and we just need some static data. So let's say data is get no, not get, head HTTP, and then we need, I think this ought to do it. So first we write that data, and I think we should be able to just use the write syscall. And we write it to our socket. We write it to our socket file descriptor, and we specify the data and the length of the data, like this. And then we just do a read from the socket to the buffer, and we read a maximum of 511. Then we close socket, we print, we'll do like this, new line, and then we print the data on the screen. And I'll just clean this up a little bit. And we return 0. Okay, so let's compile this one. Okay, we need a couple of includes for these functions as well. So we'll include stdlib.h, and I will also throw in string.h. Like this. Okay, let's try it out. Okay, we did get some data, it seems, but no, not really. Let's do it. Maybe the data needs to have these Windows kind of style new lines. like this, rn, rn, and we're sending head. I think it looks right. Let's memset our buffer as well, so it's clean and nice. I will try again. Let's do an S-trace. So we start the socket, we do the connect, we write the data, but we don't really get anything back. We get a 0. Return value. 0 indicates end of file. So it looks like it's closing down our connection. Let's try something other than Google. Perhaps they firewalled us out or anything. Let's try yahoo.com. And we'll just grab the first one here. And we'll put it right here. Search yahoo.com. We'll recompile and we'll run it again. This time it works. Great. So we read this data from the server. Okay, so what have we learned today? We have learned what kind of variables to use when creating a socket. We have learned how to use the socket command to initialize the socket, and how to fill this socket address in structure with the IP filtered through the inet address function, the port filtered through the hton-s function, and the syn family. Then we execute connect, which is binding everything together, the socket file descriptor, that is this int, and then we have the socket address in structure, typecast, and we send the address of that and its size. And if all this succeeds, then we use the regular write command to write stuff and the read command to read stuff, and then we close it. Thanks for watching and thanks for today.